In this video, we'll be looking at the concept of constant speed, which is a concept that many people don't fully understand. We're going to consider a car driving along a straight section of a highway after setting its cruise control. We'll use this picture to represent the car's trip. Watch the car moving along the road. What do you notice about the motion of the car? There are several measurable attributes of the car's trip which we might be interested in. One of them is the time since turning on the cruise control, and another is the distance the car has traveled since starting the cruise control. I'll show the car's trip again, this time adding a red bar to represent the amount of elapsed time, and a blue arrow to illustrate the distance the car has traveled since starting the cruise control. As you watch, think about how the blue arrow, the amount of distance the car has traveled since starting the cruise control, is growing in comparison to the red rectangle, the amount of time it has been traveling. In order to compare how the amount of distance traveled and the amount of elapsed time were growing, we can measure each of these quantities. I'll show how the amount of elapsed time increases again and mark off 2-second intervals to measure it. I'll also use arrows to show the amount of distance the car travels in each 2-second time interval. Each time interval has an amount of change in time, in this case 2 seconds. Also, each distance interval has an amount of change in distance, in this case 59 meters. Now let's think about how these time intervals correspond to the distance intervals. These black lines indicate how each distance interval corresponds to a time interval. The key feature here is that the size of each distance interval is always the same, no matter which 2-second time interval you are looking at. How would this picture have changed if we had used 1-second intervals instead of 2-second intervals? I'll show the car's trip again, this time splitting it into 1-second intervals. Each time interval has an amount of change in time, in this case 1 second. Also, each distance interval has an amount of change in distance, in this case 29.5 meters. Now let's think about how these time intervals correspond to the distance intervals. As before, these black lines indicate how each distance interval corresponds to a time interval. The key feature here is that the size of each distance interval is always the same, no matter which 1-second time interval you are looking at. And now we've seen 2 examples where the size of each distance interval is always the same for each time interval. Another way to say this is, for any fixed amount of change in time, the corresponding change in distance is constant. In the first case, for every 2-second change in time, there is a 59-meter change in distance. This means that for any 2-second change in time, the car will travel 59 meters. So the speed of the car is a constant 59 meters per 2 seconds. And this is what it means for the car to be moving at a constant speed. Another important aspect to constant speed is knowing that the car travels 59 meters for every 2 seconds allows us to know how far the car travels over any other period of time. For example, if the car travels 59 meters in 2 seconds, the car must also travel 29.5 meters every second, or 88.5 meters every 3 seconds, or 14.25 meters every half second. So in this case, another way to describe what it means to have a constant speed of 59 meters per 2 seconds is that the car's change in distance, in meters, is always 59 halves as large as the corresponding change in time in seconds.